Good afternoon, viewers, and welcome to this session of EduSet. Today in this lecture we will discuss about lenses and image formation by lenses, lens equation and various defects introduced in the image formed by a lens. In daily life, you may have come across two types of lenses that are thicker or thinner in the middle. Which of the following items do you think may contain a lens? An eyeglass, a peephole, a camera, magnifying glass or security mirror. Out of these, eyeglass contains a lens, peephole also contains a lens. You must have seen a lens in camera also. Magnifying glass is also a convex lens, but in case of a security mirror, it is a mirror, not a lens. So, let us discuss about lenses more. When you see through lenses, do the objects appear the same as they are? I think the answer is no. The objects appear either inverted or erect, magnified or diminished. So, what happens to the light when it passes through a lens? So, let us introduce the lenses. Lenses are very useful, for example, in cameras, projectors, telescopes, microscopes, and even our eye contains a lens. The most common lenses are spherical lenses, that is, the surface of the lens is spherical. So, there are two types of lenses, convex and concave lenses. Convex lens is the lens which is thicker at the center than at the edge. So, this picture shows you a convex lens having both the surfaces being curved or spherical, and this lens is called biconvex lens. This second picture shows you a lens with one of the surfaces being plane and the other surface being spherical. So, this lens is called plano-convex lens. This third lens is called convex concave lens. One of the surface is convex and the other one is concave. So, this lens is called convex concave lens. So, convex lenses of three types: biconvex, plano-convex and convex concave. A magnifying glass you must have seen. This magnifying glass contains a biconvex lens. Concave lens. Concave lens is thinner at the center than at the edge. So, this concave lens is biconcave lens. Both the surfaces are spherical, and as you can see in the diagram that center of the concave lens is thinner and edges are thick. So, this lens is called biconcave lens or double concave lens. Then this lens has got one of the surface plane and the other one is spherical. So, this lens is called plano-concave lens. Convex concave lens. It has got one of the surfaces being concave and the other one is convex, and you must have seen this lens in the eyeglasses. Convex and concave lenses are either converging or diverging. Now, we will discuss which one is converging and which one is diverging. Let us first discuss about convex lens. The parallel rays of light incident on a convex lens are brought to meet at a point. So, this convex lens is called converging lens. Now let us discuss about concave lens. The parallel rays of light incident on this concave lens, they move apart from each other, or in other words they diverge, and they appear to be coming from a point. So, as the rays of light after passing through the concave lens move apart, the lens is called diverging lens. So, convex lens is converging lens sorry, and concave lens is diverging lens. So, this slide shows you an example of a convex lens. The rays of light incident on this convex lens, they are brought to meet at a point. So, they converge together and the lens is called converging lens. While in case of a concave lens, these rays of light, they move apart. So, the lens is called diverging lens. So, these two slides clearly show the nature of the lenses, that convex lens is converging lens and concave lens is diverging lens. So, the convex lens bends the rays of light inwards, and you may remember converging as concentrating. So, what this convex lens is doing? This convex lens is concentrating the rays of light at a point. So, converging can be understood as concentrating. Similarly, diverging lens, which is concave lens, you can see that the rays of light move apart and they are divided. In other words, you can say, so the light bend outwards, and you may remember this diverging as dividing. Recall that light travels more slowly in glass than in air. So, what happens when light passes through a convex lens and concave lens? Light converges or diverges as some parts of the wavefronts lag behind. Let us see how this happens with the light, that why this convex lens is converging and this concave lens is diverging. So, this slide shows you the wavefronts of light incident on the convex lens. As this lens is thicker at the center and thinner at the edges, these wavefronts of light, they have, which are the portion of the wavefront which is at the near the center of the lens, has to travel more path through the glass than the portion of the wavefront near the edges. And as velocity of light is lesser in glass than in air, this wavefront bends like this, as shown in the diagram. Now, let us have a look at concave lens. So, light converges in case of convex lens. In case of concave lens, the wavefront, part of the wavefront which is near to the center, has to travel lesser part through the material of the lens. So, in that case, the light rays diverge away from the center of the lens. So, light converges or diverges as some part of the wavefronts lag behind the other parts of the wavefront. In case of convex lens, the central part of the wavefront lags behind the outer parts of the wavefront. As a result, the wavefront is converged to a point, and in case of concave lens, the central part of the wavefront leads ahead than the edges of the wavefront, and as a result the light rays diverge outwards and size of the wavefront keeps on increasing. So, this explains why convex lens is converging and concave lens is diverging. Key features of lenses. Let us discuss key features of convex lens. parallel rays are refracted inwards by a convex lens. So, these parallel rays of light, as we have already discussed, these parallel rays of light, they meet at a point, and this point where these rays of light meet is called principal focus of this lens. If the rays of light are incident from left to right, the principal focus will be on the right side, and if the rays of light are incident from right to left, they will be brought to focus on the left side, and we will have principal focus on this side also. So, a convex lens has got two principal focuses on either side. Center of the lens is called optical center. The distance between optical center and principal focus of the lens, that is the distance of f from C, is called focal length of the lens. A convex lens, as I have already discussed, has got two principal foci, one on each side. F and f prime are the two principal foci of this convex lens, and the line through these principal foci and optical center is called principal axis. So, this red line is called principal axis passing through these two focal points and the optical center of the lens. Now, similarly, we will discuss the key features of concave lens. The parallel rays of light are refracted outwards, and these refracted rays appear to be coming from a point, and this point is called principal focus of the concave lens. Similar to the convex lens, the center of the lens is called optical center. The distance of f from C, that is the focal point or principal focus from the optical center, is called focal length of the lens. So, this is the distance of f from this optical center is called focal length and is denoted by small f. Similar to the convex lens, a concave lens has also got two principal focuses, one on each side, and a line passing through these two principal focuses and the center, optical center, is called principal axis of the concave lens. Now, a light ray is incident on a convex lens. Which one represents the path of the light ray? So, there in this exercise, we have got three options. This ray of light is incident on the convex lens. One of the rays X, is moving away from the principal axis. This one moves undeflected, and ray Z is bent towards the principal axis. And from the previous discussion, you can conclude that the path Z is the actual path which will be followed by this ray of light incident on the convex lens, as it will be bent towards the principal axis by the lens. Now, let us discuss the same question for concave lens. In case of concave lens, the incident ray will be deflected away from the principal axis. So, out of these three, the option A, in which the path X, the ray of light bending away from the principal axis, is the correct answer. So, this exercise tells you about the path followed by a ray of light. Now, let us discuss about image formation by a lens. First of all, when the light from a point of an object enters our eye, we can see the point. So, how we are seeing the objects? Because light after reflection from the objects, it enters our eyes. So, let us have a convex lens and a point O placed here. So, the rays of light emerging from this point O after reflection after refraction from this lens, they will be brought to meet at a point, and this point is called image of the object. So, this is the object, this is the image, and when a screen is placed at this point, the rays of light after reflection from this screen fall on our eye, and we can see this image of the object on the screen. So, this is how we see the images. Now, images are of two types. First is real images. Now, what are real images? Let us discuss the same example again. The light rays emerging from object O after passing from this lens, they actually converge to a point or meet at a point. So, when the rays of light after refraction from a lens actually meet at a point, the image formed is called real image, as this image can be captured by a screen. So, if you place a screen over here, you can see this image on the screen. So, image can be captured by a screen, and hence this image is called a real image. Now, second type of image is virtual image. What happens in case of a virtual image? Let us take a concave lens and an object O placed here. The rays of light after refraction from the concave lens, they will move apart, they will never meet each other, but these rays of light, to the eye of an observer, these rays of light will appear to be coming from this point I. So, it appears that light rays diverge from this point I. So, no rays actually come from the image, and this image is called virtual, as this image cannot be obtained on the screen. If you place a screen over here, if you place a screen over here, you cannot get the image on the screen, because the rays of light are not actually meeting. So, this kind of image is called virtual image. This virtual image is also formed by convex lens when the object is very close to the convex lens. So, this example shows you that the light rays will not meet, but they will appear to be coming from this point I, and the image formed will be virtual image. So, convex lens in certain situations forms real image, in certain other situation it forms virtual image, but concave lens always forms a virtual image, as it will always diverge the rays of light. So, let us discuss the graphical construction of image formation by a lens. Let us discuss the construction rules which are followed while constructing an image formed by a lens. In ray diagrams, we use symbols to represent the lenses. So, this symbol is used to represent a convex lens, and this symbol is used to represent the concave lens. First rule, rule 1 for the construction of images: a ray parallel to the principal axis is taken. This parallel ray, when enters into the lens, will pass through the principal focus of the lens. So, a parallel ray to the principal axis is refracted through the focal point. Rule 2. A ray passing through principal focus like this after refraction from the lens is rendered parallel to the principal axis. So, rule 1 is a ray parallel to the principal axis passing through focal point. Rule 2 is ray passing through the focal point rendered parallel to the principal axis. And rule 3 is a ray passing through the optical center of the lens. Any ray which passes through the optical center of the lens will pass straight on. Its path will not change. It will travel undeflected. So, these three rays are used for construction of images by convex lens. Let us discuss this three ray diagram again. Ray 1 parallel to the, this is an object. From the object, ray 1 parallel to the principal axis passing through the focal point. Ray 2 passing through the optical center, passing and going undeflected. And ray 3 passing through the focal point and being rendered parallel to the principal axis. So, this is how we construct an image on the other side of the lens. We take a point of an object and three rays of light are taken from that point of the object. As you can see from here, three rays of light are taken from same point, and the point where these three rays of light meet, the image of that point will be formed. So, this slide shows you that from this point of the object, three rays of light after refraction through the lens, they meet at a point and image of that point will be formed at that point. So, this is how we form an image in ray diagrams. This was the case of convex lens. So, this again shows you the formation of image in case of convex lens in symbolic form. Next, we will discuss the construction rules for concave lenses. First rule, a ray of light parallel to the principal axis after refraction from the lens will be deflected away from the principal axis, and this ray of light will appear to be coming from the focal point. So, this ray after refraction is deflected so that it appears to be coming from the focal point of the lens. Rule 2, a ray of light directed towards the focal point of the lens after refraction through the lens will be rendered parallel to the principal axis of the lens. So, this is rule 2. And rule 3, a ray directed towards the optical center of the lens will pass undeflected, as is the case with the convex lens. So, these are three rules for construction of image by a concave lens. Let us discuss these three rules again with the help of a diagram. This is an object. From a point of this object, a ray of light is taken parallel to the principal axis, and this parallel ray of light will be refracted in such a way that it will appear to be coming from the focal point of the lens. Another ray of light from the same point of the object is directed towards the optical center of the lens, and this ray of light will move straight on without any deflection. The third ray of light from the same point of the object is taken to be directed towards the focal point of the concave lens, and this ray of light after refraction from the lens will move parallel to the principal axis. And where the image is formed, in this case, these rays of light will never meet. These three rays are moving away from each other as the lens is diverging, but they will appear to be coming from the same point. So, the point from where they appear to be coming, a virtual image will be formed at that point. So, this diagram shows you how we construct with the help of three ray diagrams the image in case of a concave lens, in which case the image formed will be virtual one. Now, let us discuss the images formed by a convex lens for different positions of the object, and we will see that for different positions of the object, the image formed will be of different nature. In some cases it will be magnified, in some other cases it will be diminished, and it will be virtual also in case of convex lens. So, first of all, we will discuss a situation when the object is at infinity, and when the object is at infinity, the rays of light coming from that object will be parallel to each other, and these parallel rays of light after refraction through the lens will meet at a point which is called principal focus. So, the image formed will be real as the rays of light are actually meeting at this point, and the image formed will be at f real, inverted and diminished. So, this is the case when the object is at infinity. So, this shows you an example of object being far away and how the inverted image of the object will be formed by the lens. Next situation is when the object is beyond 2f. This is the focal point. This is double the focal point of focal length of the lens, which is called 2f, and the object is placed beyond 2f. Now, to construct image for this object, as I have already discussed, we will take a ray parallel to the principal axis, and after refraction through the lens, this ray of light will pass through the focal point. Second ray is taken to be passing through the optical center, and this ray will pass on undeflected. The point where these rays meet each other, the image will be formed. So, in this case also, the rays of light are actually meeting each other. So, a real image will be formed. So, image formed is between f and 2f, real, inverted, as you can clearly see the rays of light coming from the head of the object, they meet at this point. So, the image formed will be inverted, and size of the image you can clearly see is smaller than the size of the object. So, image formed will be between f and 2f, real, inverted and diminished. So, this slide shows you the example of the situation when object is placed between f and 2f. Next, we will discuss when the object is exactly at 2f, twice the focal length of the lens. In that case, again we take the two rays of light, one parallel to the principal axis passing through focal point and the other through the optical center, and as you can see, the rays of light will actually meet at a point and they meet at 2f. So, when the object is at 2f, image formed is also at 2f, and as the rays of light are actually meeting, the image formed is real, inverted and of the same size, as you can clearly see that size of the image and size of the object is same. Next situation is, this slide shows you the example. Next is when object is between f and 2f, that